Hi, we are going to talk about graph transformations. This time we're going to talk specifically about shifts, or also known as translations. So in general, to be successful at graphing functions, you need to understand their parent functions and how various transformations change their graphs. Parent functions are your basic functions that you studied before. So if we consider a positive value of k, then this is how shifts or translations are going to work. If you take function f of x and add k to it, that's going to make this graph shift k units up. If you take function f of x and subtract k from it, that's going to shift k unit down. If you do the function where you're going to add x and k together, so k is getting added to x, there's going to be horizontal shift k units to the left, and when you subtract, it's going to be horizontal shift k units to the right. You need to be careful with horizontal shifts because if you look at that, it sounds like when you do x plus k, you should go higher and go to the right, but no, it's not. It's actually the other way around. And for the problems that are going to follow, we want to identify our parent function and graph it by graph the function as given to us. Here are our examples. So the first one is f of x equals x squared. Our parent function here, f of x, is going to be, so let's call it g of x equals x squared. And what we do here is it's x squared minus 4, which means the graph has to be shifted because we're subtracting 4 from the function itself. We're going to shift our graph 4 units down. So 1, 2, 3, 4. And what you do essentially, you find some points on the graph that you can easily figure out, and you shift them 4 units down. Okay. And then you are going to connect. There's going to be another point a little higher here that I can move 4 units down. No, I'm sorry, hold on, it's this point. 1, 2, 3, 4. And 1, 2, 3, 4. And then we connect the dots, so the shape's going to stay the same. It's just going to be 4 units lower. Our next example is f of x equals x, absolute value of x plus 1. Our parent function here is going to be absolute value of x, which is, that's what the graph is. And we do plus 1. We're adding 1 to the function. That means our function is going, our graph is going to shift 1 unit up. Which in this case, it's pretty easy. And carefully, remember these are two rays, and this is what our graph is going to be. Our next example is f of x equals x minus 3 squared. So this is where it is going to be a horizontal shift because the parent function g of x is going to be x squared, and we're subtracting 3 from x, and then we're squaring that. So here it was a horizontal shift 4 units down. This was a vertical shift 1 unit up. This is going to be a horizontal shift. Now we're doing x minus 3. It's actually going to shift your graph 3 units to the right. So we take our points, several points, and move them to the right. 1, 2, 3. 1, 2, 3. 1, 2, 3. This point 1, 2, 3. This point here 1, 2, 3. And then our graph is going to be this. Let me point some arrows to our new graphs. Next one, f of x equals x plus 2 cubed. So the parent function here is going to be x cubed. And now we have to determine what's going to happen here. So it's x plus 2 being cubed. So So 2 is being added to x, and then you're going to cube it. This is going to shift your graph 2 units to the left. 1, 2, 1, 2, 1, 2, and that's what our graph is going to look like. Several more. So example 5, f of x is absolute value of x plus 4. So x plus 4, 4 is inside the absolute value, you're adding that to 4. The parent function here, of course, is going to be absolute value of x. This is going to make your graph shift 4 units to the left. And that's what we do. 1, 2, 3, 4, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and like that. So that's the graph of our function that we're trying to graph. Example 6, we have quadratic function, so it's f of x equals x squared plus 1. We're adding 1 to the x squared. The parent function here is going to be x squared, and this is going to shift the graph 1 unit up. So we'll take points, move them 1 unit up. And then connect that. Next one is f of x equals square root of x plus 2. So square root of x is going to be our parent function. And then plus 2 outside of the square root is going to be shifting it 2 units up. 1, 2, 1, 2. And I have another point here, 1, 2. And then we connect that. This is our function. And the next one here is going to be f of x equals square root of x plus 2. Our parent function is still square root of x, but because here we're adding 2 to x, this is going to be a horizontal shift plus 2. So horizontal shift of 2 units to the left. 1, 2, 1, 2, and 1, 2. Now remember, the shapes of graphs don't change. What changes is where that graph is going to be positioned, because you are shifting it. A couple more examples. You can have transformations going both transformations happening at the same time. So you can have a horizontal and vertical transformation being applied in the same problem. And when you see problems like that, just carefully break it down, and then you will be able to graph it. So what do we have here? Obviously our parent function is going to be x squared, because x squared we have here. What do we have here? We have x plus 3 squared. That means it's going to shift 3 units to the left. And then we also have plus 1 on the outside, which is going to shift that graph 1 unit up. And we are going to apply that in that order. So we're going to take our 0, 0. 3 to the left, 1 up. 1, 2, 3, 1. Take this point, 1, 2, 3, 1. Take this point, 1, 2, 3, 1. Take this point, 1, 2, 3, 1. And take that point, 1, 2, 3, 1. And now we are going to get this graph. By the way, here it wouldn't matter whether you go up first and then to the left, you will get the same graph. But in general, there is something called order of transformations, and you have to perform them in the correct order to avoid any problems when it does matter. Now let's do this one. So we have our parent function, I don't know what I wrote here. Our parent function here is g of x is still absolute value of, well, it's going to be absolute value of x. What do we have here? X minus 2 inside the absolute value. That is going to impact that horizontally, and it's going to be 2 units to the right. And then you have minus 3 on the outside, which is going to make the graph go 3 units down. So 2 to the right, 3 down. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. Let's do a couple more here. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. And then the graph is going to be like that. I do want to mention one more time that the graph's shapes and orientation does not change with translations. It just moves the same graph around the coordinate plane. Okay, so I hope this helps.